All right, here's the screencast for 8.3 part 2. So last time we were talking about dot products, right? So dot products are literally going to be the parallel components, right? You're trying to see the projection of A onto B, right? Literally, which parts are parallel to each other, because if they're perpendicular, the dot product is going to be 0. Now so dot products tell you how parallel two vectors are. Now, if you want to know how perpendicular vectors are, that's called a cross product, which the book goes into, and you work with physics and other math goes into it. If you have questions, you can just look up, cross product. But we are only doing dot product. Dot product is how parallel two vectors are onto each other. Okay, so the projection of A onto B. So recall that the projection is the dot product over the absolute value of B. And here, taking the absolute value gives you your magnitude, since direction doesn't matter. Normally, direction is positive or negative, but by taking the absolute value, we only get the number. We won't be told the direction. So this is only the magnitude of the projection. In order to give it the same direction as B, we have to multiply it by the unit vector, aka vector B divided by the absolute magnitude. That way, the hypotenuse would be 1. Remember, unit vector has a length of 1. So this is the part that is the projection, and then, this is the part that's the projection, this is the part that's the unit vector. This part down here is the full projection vector with magnitude and direction. So to find the projection of U onto V, what we're going to do, we're going to take the dot product, right? This is going to be -1 times 4 plus 5 times 6, so -4 plus 30 is 26. Okay, and then we need the magnitude of V. I keep saying absolute value. It's just the magnitude of the vector V is the absolute magnitude because it's just the number. Okay, so that is going to be 4 squared plus 6 squared, so 16 plus 36 is going to be square root 52. Okay, and then just to find the projection of, projection of onto V. Okay, so whatever's onto goes on the bottom. So I have I'm looking at the equation, U dot V over absolute value, the magnitude of V, squared times the vector V, which is 4, 6. So times the vector V. So times vector V. I probably should write it this way. Times vector V. Okay, so this is going to be 26 over square root 52 squared. Okay, so the square root and the square cancel out, and then multiply by 4, 6. So I have 26 over 52 times 4, 6. So what this is 1/2 times 4, 6, and since this is scalar, it's just a number, I multiply it out and I see it's going to be 2, 3. That is the projection of U onto V. Awesome. Okay, and then we need to write U as a sum of two orthogonal, right? So two perpendicular vectors, one of which is the projection of U onto V. So this is what we just found. If I name this vector W, this is going to be my vector W. All right, U, V, W just makes sense that I name it W because it's next alphabetically. So I want to write U as the sum of two orthogonal vectors. Okay, so one of them is W. I'm going to name my other one Z. Okay. So I know U is going to be -1, 5. Okay, -1, 5. We said vector W is 2, 3. And then I need to find what my vector Z would be. So I'm taking my vector U and subtracting vector W, and that will be my vector Z. -1 minus 2 is -3. Alright, so I was taking my x, now I'll take my y. 5 minus 3 is 2, so that's my vector Z. So I'm going to write U as the sum of two orthogonal vectors. My first vector, 2, 3. My second vector, -3, 2. Alright, and I know they're orthogonal because if I take W dot Z, that should equal 0, right? 2 times -3 plus 3 times 2, because I take the x's, and then I take the y's. And I get -6 plus 6. Okay, there's 0, so I know they're orthogonal. So you don't need the stuff in pink. You just need the one I boxed in blue. All right, a person pushes a box with a constant force 40 newtons at a constant angle, 45 degrees. Find the work done in joules to move the box 12 meters. So joules are just the unit This should say find. Okay, so my force is 40 newtons. It's at an angle of 45 degrees, and my box is going forward 12 meters. So I want to know, like, if I'm pushing down on the table, not all of my force is going to be causing it to move forward. So only some of it, right? Part of my force is pushing down, right? That's my y component, and part of it is going in the horizontal direction. So this is the portion I want, right? This is the portion I want, and this is just going to be, let's see, this component. So if I take cosine 45, so cosine 45 degrees is adjacent over hypotenuse, right, over 40. So the x component will just be 40 times cosine 45 degrees. And this is the component I want because this is the component that's parallel to my motion. Okay, let's bring it back for a moment. So in physics, right, in physics, work is equal to force times distance. But really, it should be work is the dot product of force and distance. So remember, the force must be in the same direction of motion. Here we wanted the horizontal component because that's what's causing it to move forward. If you were dropping something, the force is vertical, so you'd want the vertical component. Okay. So my work is going to be equal to force times distance times cosine theta, right? Because it's F. So this is my force, which is my hypotenuse, times cosine theta, and that's my theta is 45 here. Okay, so if I plug in, I get 40 times my distance of 12 times my theta, which is cosine 45 degrees. All right, so we get 339.4 joules. Work is just in joules. So I told you it was in joules, so I told you the units to put. Okay, that's method 1 using physics, but what we could do, I'm going to use method 2, which is using components. All right. So I said work was just force dot distance. So my force here, right, let's write my force vector in components. So the x component is 40 times cosine 45. My y component is 40 times sine of 45 degrees. My distance vector, right, it's all in the x, so it's 12, 0. There's no component in the y. So if I take the dot product, right, force dot distance, right, we multiply our x's together. So I have 12 times 40 cosine 45 plus 12 times my y, which is 40, 0, right, because that's the y. Here is 0 times sine of 45 degrees. What you notice is, 0 times anything, that goes away. This is exactly what we ended up with up here. So it works out. All right, so now if you go to the homework, you should be able to finish the rest of it, right? So all of these right here, right? This is exactly like the first example I did, and then the rest are all about force and stuff. So try as many as you can, and then we'll go over some in class.